Everybody, I've been working in my shop and making things better and prettier and more organized, and for a variety of reasons I haven't filmed a lot of those things. But this next piece of shop infrastructure that I'm working on right now is just too, well, it's going to be too awesome to not film and document the entire process, and that is because I'm going to be ripping off Saunders Machine Works vices. Not actually ripping them off. Well, I am ripping them off. I'm just not going to sell them. These ones are just for me. And we're going to start with work holding, which is like the entire point of doing this is to increase my work holding capacity, because it's like probably the most important part of machining, the most difficult, at least for me. The software side of things, I know the Fusion 360 toolpaths. I know how to use those. I know how to get the shape I want. I know how to get accurate parts. But holding on to those parts is probably the hardest part. So we're using a lot of Saunders Machine Works inspired things over here. And I've been thinking about it a lot. And this morning I was lying in bed and I figured it out and exactly how I'm going to do it. I'm really excited and I'm going to show you guys about it. So I have 3 different pieces. I have this, God, I'm forgetting the exact dimensions of it. I think this is 2.5 by 1/2 inch. Or that might be 3/4 actually. This is, I think, 3.5 by 1/4. I can't remember. I have all these different pieces, right? And all these pieces are going to be different ones. So I think this is going to be the jaws. There's the movable side. I think this is the movable side. And then there's the fixed side. I think this big chunky piece is the fixed side. So I have to hold all these down. I have enough on that material to make 3 pairs of vices, so a fixed and a movable side. And how I'm going to hold these here is, like I said, the work holding solution is the most tricky part. And what I would like to do is make a fixture for these, but I've been using MDF and I've had so many problems with it, especially since I installed my ghetto water blast. There's a water bottle and it goes around and there's a little valve there, and this is air and it pushes water out. It works pretty good, but it was soaking everything in water and it ruined a part in my MDF. So that's why I'm actually building these vices. So what I'm going to do is I'm going to use the super glue method of Saunders Machine Works to put some tape down here and then put super glue in between them and glue them on. And the beauty of this is I needed a very flat thing to do this on. And actually my fixture plate is close, but I think it's probably off by about 10 thou on the Z height all around. But these offsets I machined the tops of them perfectly flat, so I know these are flat. And then I was using this to hold this piece of under metal, which I was machining, and I have a whole bunch of these. I have like 30 of these for the project I'm working on, the Iron Man suit I'm building. But this extruded stuff is very flat, so this now becomes a very flat surface that I can put these on, and I know it's true and trammed into the Z. So everything is going to be really Gucci in that point. And then because it's not MDF, I'll be able to shower this in water, and the painter's tape shouldn't come up unless I get it like really wet, but I'm not planning on doing that. And this is going to be a really awesome way to hold this up down and work on it. And then the thickness of the painter's tape is actually going to be my air, so when I cut these things free, it can actually push all the way through and come down like a few thou below the surface of this. And this is my probe back here, and so I've did the math and I got it toward my probe. We'll put this just the Z height of this just at the bottom of this, but not on the bottom of this. And then I can cut through and cut into the tape, hopefully without cutting into this. And if I do, I can still use this piece because the stuff I'm building out of this is really loose tolerances, and a little bit of marring on the top will not be a problem. So this is really exciting. Let's actually show you what I'm doing now. Guys, we're gonna take the voiceover for today nice and easy, because some of this footage I was watching before doing the voiceover, and I just found it very relaxing. So I prefer to kinda let some of the footage just speak for itself, though I am going to be here to add a little bit of commentary. Right now I was just prepping the material with acetone. That's a very important thing to do. It helps this tape stick to a much higher degree than it would on any type of oily or dirty surface. And then we'll slowly lay down and build up a bed of tape
I was taking great care here to make sure that I was getting good coverage without any overlap, because that would add a error in my Z if there's 2 layers instead of 1 layer of tape. And then I braid it down with my braiding tool, and then cleaning it up with a razor blade there. Even more cleaning of acetone now on the workpiece instead of the work holding. Love the sound of tape being pulled. It's a lovely sound. That piece wasn't going down correctly. More braiding with the braiding tool. That helps just really stick it down well. And here we go with the more exciting part, which is laying down the super glue. And then I ended up moving it around with a little poker stick that I keep a lot of these guys on hand in my shop. Ended up not doing that the entire time, but starting off with it. And then I have some offcuts of aluminum sitting around that I've used for a variety of reasons, and right now I'm using them as spacers in order to space the 2 pieces of work roughly an inch apart, and then also very parallel to each other. And that's important because the front one is parallel to the surface of this plate, and that plate will then be parallel to the surface of the machine. Adding a little bit of accelerant now, which mostly unnecessary.
I was trying to record the unboxing of all these parts, but my camera ran out of batteries. I got these bolts, got this little bag of bolts for attaching these to the fixture plate. Aren't these cute? Look at that, they got a little exclamation mark on there. Be careful with this bolt. I also got these really nice countersunk ones. Look at those. That's what's going to hold the jaw to the fixed and the movable side of the vise. And then I have this nice big long plastic bag. Not that I'm really about the single-use plastics, but we have a piece of ground tight tolerance stainless steel. That's awesome. And then it's only tight in one spot, so we'll see if it's tight or where it sets on the other side. So one way it should be like within 2 thou. So at 249, 248. So it must be 2485. It could be the 248. Huh, they're exactly the same. That's weird. It's a perfect square. That's good to know. It's actually better. Helps my design. I wonder if it's the same down here. 249, 248. It'll be nice.
And here we are on the machine. Unfortunately, I missed recording of the facing pass of this bar stock to begin with. But don't worry, there's plenty of machining footage to come. Started off using this 3-way prying tool that contractors use a lot to get these guys off, and I ended up switching to a more elegant way because later on I was marring some of the parts and I had to correct it later. Time for the scary part. Using a saw that can easily cut your hand off is always a little bit terrifying. Good to have that fear though, because without it, you cut your hand off. Getting towards the end is even more terrifying because my hand has to be closer to the saw. ended up flipping that part around because you want to present as little material to the saw blade as possible when cutting, even if it means you have to go for a longer cut. So that's how I'm cutting this, and started off holding it a different way, the long way, and now I'm holding it the short way from the saw's point of view. And this part required the most number of cuts. I'm cutting right now the vice jaws, and I've already cutted the fixed and moving side of the vice. Because I'm using a stop, these are all coming out to the exact length, which means I won't have any surprises when running the cam and running the machine, because the stock will be the exact size that I put into the code.
For those of you following the channel, you know this isn't just like a CNC channel. This is a channel about me building an Iron Man suit. And I was building this guy and it came loose and I had a bunch of problems with it. And I'm building the vices to hold this because my other solutions weren't working. And then just today I realized I could probably use the same super glue method that I'm using to make the vices to also make this. Therefore, rendering the vices a little bit null. The sunk cost fallacy, we're going to finish them because I'm almost done with them. I just have the fun parts left to do. The fun stuff. I've done all the hard work for them. And they'll still be really nice to have. Make things faster and more efficient, that's for sure. Yeah.
I've done a lot of this. I became very practiced at doing this work holding method, the Saunders superglue tape method. And those of you who don't know, this is a method that John Saunders presented, and the kid who works for him as well. They both presented for a work holding solution, and it works pretty well. It's a bit labor intensive though, of course. Which I'm glad I don't have to do as much of it because I'm going to have vices, or I have vices now. As of recording this, I have vices because these did in fact work. But it's good to be able to have this super glue method in my bag of tricks, because you never know, I may need to machine a part where I have to get all the way down on the sides or something like that, which you can't do with a vise. So in that regard, the super glue method is superior. Where it's not superior is in the ease of use. The amount of time it takes to set this up and the amount of care and energy it takes to set this up, as you can see, is quite labor intensive. So chucking something in a vise is way less labor intensive. But it's worth the energy to do this in order to have some vices, and that's exactly why I went through all this trouble. Doing a whole bunch of them here at once. I really like kind of watching the assembly line of it. This right here is me setting my work coordinate systems. I'm writing it on there so that I know, because this is one of the first time I've messed with different work coordinate systems. Essentially what it is each of these parts has a different 0 on the machine, and the 0 starts with the G code line 54, and then it goes to G55, G56, G57 in that regard to change. And essentially what I was doing is the same exact operation but in different locations on the machine by changing the G number. And you do that inside the CAM package. So inside of Fusion 360, you set the G54, G55, G56. And on Gerbil, which is the G-code sender that I use, you can go all the way up to G59. So you can have, I believe, 6 work coordinate systems. And I used all 6 at the end of this when I was machining the vice jaws. Some of this footage is slowed down or normal speed, and then it's obviously some of it is sped up as well.
You can see here I have the rough geometry for the holes out here, and one thing that's just really cool is you can see that I've set up my Z height perfectly, where it comes in and it either doesn't touch the tape, or in some cases it peels it up, or in some cases down here it pulls up just a little bit, but it is not even touching the plate I have under here. So I've had a lot of trouble getting my Z height right, and I think I might be getting better because it looks pretty good right now.
And here's the kind of fun stuff, in my opinion. This is 3D geometry. This is full simultaneous 3D geometry. So all 3 axes are moving simultaneously while in the cut in order to add this sloped 1.8 degree angled part, which is very important for the functionality of the vise. And this is being done with my ball nose end mill as well as this chamfer, which I really loved how this chamfer came out. I actually liked it more than my chamfer tool. I used the trace tool path for doing this, which is a tool path I've never used in Fusion 360, and I absolutely loved it. It worked better than my chamfer tool, and I think it's because my chamfer tool is not well modeled inside of Fusion 360, so it's not that accurate. And then this is my other favorite tool path. I've done this a lot, but I still love it. I think it's beautiful. This is a helical interpolation of a thread, of a quarter 13 thread, excuse me. And you can see, after cutting that, this thread fits right in there, which is awesome. One of my favorite things you can do in modern machining, or CNC machining. I just think it's the coolest thing in the world. I mean, doing 3D adaptive removals and 3D finishing is all very cool as well. And the pathway I used to get that angle in there is a 3D finishing path that I was able to use for roughing. If you're really familiar with CNC, you know kind of what I'm saying. Again, I moved away from using this method of work removal a little bit later in the video because these parts came out pretty much perfect, but they were marred slightly by the removal of them. So I changed that in the future when I removed the fixed side of the vise and the jaws. This is the moving side of the vise right now. And this is my deburr tool, which I'm also a big fan of this tool. Really cheap tool. You can get it at Home Depot. I should make one of those out of brass. That'd be a fun manual lathing project at some point. Brass feels nicer than in some parts. A plastic part, though that Husky tool feels pretty solid. Last time I was at the metal distributors getting some metal, I bought a nice chunk of brass, and I'm going to make a scribe out of it pretty soon. So I don't have a really good scribe, and having a big solid brass one would be really nice. I do kind of like doing these voiceovers. It's almost like a one-way podcast. I don't follow Bill Burr's podcast, but I know it's just him talking. To me, it kind of feels like I can't say simultaneously. Can't say that word apparently today, but feels like a podcast about building stuff while also watching a video about building stuff, and I kind of enjoy that. Doing a facing pass here, which is what I missed on filming earlier. I think on the last 2 operations I missed that. Now we're off to a roughing strategy here. This is 3D removal. I did 2 facing passes because this is a thick part and I wanted a nice smooth finish on top. Though ultimately I realized wasn't super necessary for this because the part that was actually faced was not a critical geometry. The floor of this was a critical geometry, and I actually ended up messing something up in cam and ruining, not ruining, but one of the fixed sides was out by 5/1000ths of an inch. Probably will never have to use the revises at once, so it may never be an issue, but if I really need to, I'll have to shim the jaw in order to get it to work. This pathway this is one of the worst things I do with my machine, is the plunging of this tool into the metal like that is tons of chatter. And I really need to figure out a way to pre-drill or do these parts a different way, because it's one of the only operations I do regularly that produces a lot of chatter, and chatter is not very good for tool life, not good for surface finish. It's not a good way to machine. Here I am removing the little burr that's left at the top of the thread when you get done with a helical, or when you get done cutting those threads, there's always a little piece of aluminum that gets caught at the end. And eventually I'm going to figure out a way to do that removal of that metal using the machine. That's something I would like to do with an 1/8 inch end mill. Especially if I ever do a production run on something, I'm going to figure out a way to do that. But it's not something I've done yet. Nothing wrong with cutting it away with a razor blade either. It's very easy to do with aluminum. Now we're coming in and roughing out the parallel into the jaw. Here again, you can hear the chatter of this tool plunging in. And I have my plunge rate set really low, and I've done everything I can to try to get rid of that. It's just my machine is not rigid enough. It's not a good way to machine with big Haas CNCs and stuff like that either, but it's better than doing it on this router. And then here into the parallels, I am machining in the pocket for the stainless steel bar that will go in here and be the jaw face. So I wanted something that won't wear down. And this is really cool. This here, I'm finishing the floor with a much larger depth of cut, or width of cut. Optimal load is what it's called. So I was doing a adaptive removal strategy to finish the floor, and then I used a contour strategy to finish the walls, and that gives me a really good finish on both the floor and the walls. Now we're setting up to make the nuts, the tapered nuts, or tapered washers, excuse me, that hold down the moving side of the vise. For the life of me, I'm not able to drill accurate holes using this method. Even if I punch them in exactly the same place, it seems like they always move on me. So if anyone has any good tips on how to drill better holes with a punch and a drill press, I'm not really sure why I can't get holes, but I always seem to get a little bit of wandering of my holes. Could be that I'm not starting with a large enough pilot hole, or I'm not starting with a small enough pilot hole. I'm not sure. This new improvement to my bandsaw has just been super useful. I've used it like a ton since doing that Indiana Jones video that I'm sure a lot of you guys watched. Here we are using the Saunders tape and glue method to do something that's not strictly machining, but to do a little bit of grinding for this angle that I'm adding. And it worked very well. Tape did start to come loose from all the water I was putting on this thing to keep it from getting too hot, but it didn't come off. I was able to finish all the grinding on all the parts. And as you can see, it was coming fairly loose. They popped off pretty easy, but they held through the entire operation. So here I am grinding in the bevels in order to align the washers with the moving side of the vice jaw, and doing just a little bit of lapping on the very flat surface of my bandsaw just to give them a nicer surface finish, really, and to pull off the marking fluid. Here we are to the method that works much better for removing these things. I don't have soft jaw pliers, so I made some with tinfoil, or not tinfoil, aluminum foil, and it worked well. I'm going to clean up all the burrs on the bottom side now. We're working on the vice jaws. Still in my Indiana Jones costume from making my bandsaw video. Using both a deburr tool and a file to do that. And here we're going to mark and cut the jaw face out of the stainless steel. And this stainless steel would not hold up to a lot of use if I was machining a lot of steel. I don't machine any steel in my router because my router can't handle it. So this stainless steel is so much harder than aluminum that it's essentially a hard jaw face. There's no need for me to get like high carbon steel or something like that for aluminum. Stainless steel works just fine. I'm adding a little relief at the bottom because the tool I used to cut it had a 10th corner radius, and I just wanted to make sure they would fit flush on the bottom. Not that it was 100% necessary, because the stainless steel fitting into the cavity perfectly is not a important tolerance thing, right? It's not a critical dimension, but went ahead and did anyway. And then I am just marring up all the surfaces with sandpaper in order to give the aluminum and the steel a little bit more tooth, so that the super glue that I'm going to add them with has a little bit more surface area to bite onto and grab onto, just to hopefully make it more likely that they won't ever come out. Super glue is incredibly strong. In Mythbusters, they took two 4x4 pieces of, or it was a 6x6 pieces of steel tube. They're about 6 feet across, put 4 drops of super glue, and then clamped them together really tight, which spread out the super glue and gave it a lot of surface area. But still, they hung a car by it for over a half hour before the car finally fell. So super glue is very, very strong. And there's a lot of surface area on these parts, and there's also a good pressure fit. I'm unfortunately having to kind of hammer them in on some of these parts. And the reason that's bad is because it could warp the parallel a little bit. The reason they're not fitting on all of them is because my machine is not perpendicular across the entire machine. It's only perpendicular in the top right of the machine, which I'm not sure if that was an assembly error when I put the machine together, or if it came from the factory like that, because my machine got really banged up in shipping, and it's also possible that that came from that. At some point I'm going to take apart my machine and try to get that error out. I can cut really precise parts, small parts, if I cut them in that specific accurate corner of my machine, but if I try to do large parts, they're slightly out of square. For a low tolerance part like the Mark 1, it's not a huge deal. And I'm just doing a kind of test fit of these guys, putting them together and seeing how they look, and I'm going to take some measurements on them as well, see how accurate they are. Over here on the surface plate, had a little bit of trouble getting the dial indicator to work, but I gave it a good college try.
Alright guys, I'm coming at you from my granite surface plate here. I know this might be kind of weird since you've been listening to a voiceover the entire time, but I'm doing a little testing of the parallels here. So those are the most important part. And the machine's not running, so you can hear me talk. Okay, let's see. I'm trying to get this dialed in with the fine adjust. Okay, across here I'm seeing like maybe. Now we're pretty much pegged right at like 3 thou there, 2 thou. So we're within a thou there, somewhere between 2 and 3 on the dial. So let's take this off, and we'll put this one on. I can tell these are really flat, moving them around on here. Okay, now we're at 1, which is where we were at earlier. So we were between 1 and 3 over there. I'm coming into like -1 here. That's about 0 the entire way. We're about 1 there. I would say these guys are in about. These guys are really accurate. I would say they're within a couple of thou. It's kind of hard to tell. They're really small surfaces to measure, but we're within a couple thou between this parallel and this parallel, and that's what we want.
And the last step to building these guys is to put in the alignment pins for the fixed side of the jaw. This may not strictly be necessary for the tool, because they are held down very tightly and very precisely, because I made my tolerances perhaps a little bit too tight on the holes for that. The threads were cutting, the screws were cutting a little bit as I put them into the fixture plate. But so those 2 bolts that hold it down would probably be enough to hold the fixed side of the vise down. That being said, you can never have too good of a clamping mechanism when machining, and this is something I've learned the hard way. The first time I tried to make vices, I put 1 bolt across them to try to hold them to the fixture plate. Worked terribly, was not good at all. So having extra rigidity in the system is always a good thing for machining. If this was having to fly, if this was an aircraft part, over designing things could be a negative because you have too much weight. But weight limitations are not a factor really in machining, and usually more weight is good. So having, like I said, more rigidity, more bolts, more fasteners, as long as you're not getting to the point where it's becoming cumbersome to affix to the vise or to the table or whatever, it's almost always a good thing to have more clamping force than less.
Fuck. Oh.
The first time was a failure, but I went in with the torque wrench, and well, you'll see what happens.
That works. We needed a torque wrench. We needed more force on there. Okay, guys, I have so much I could say about these things, though I'm sure I said a lot of it when I was doing the voiceover for this guy. I did the voiceover because the sound of the machine, I couldn't really talk over it. And it was like a 5-day fucking project. So me talking through all of it just got kind of confusing. So I decided to film it all, do the voiceover, and then talk to you guys at the very end. I was a little worried. I didn't think they were going to go on there. I pulled it off. It's like, no, they're not going to work. But because I tried using some of the things that Saunders said, where you turn it back and then you turn it back down, like a quarter turn or something like that, and that just didn't work. But then I put a torque wrench on it, and I put 20 foot-pounds of force on there, which is a decent amount. They say on theirs 35 max. I don't like going over about 20 on aluminum, but that thing is fucking on there. didn't even fully have in my mind how these things actually functioned until I just got that and used it. But now I understand how it actually works, having built it. And it's actually a really clever design. I gotta give my hats off to Saunders. If you happen to see this, John, I've been a little bit skeptical about your thing, but because I couldn't wrap my head around how it works. Now that I see how it works, I'm like, this is just really brilliant. It really is. It's a really well-designed product. It's very streamlined. It works really good. I'm super happy to have my own pair of this. I couldn't afford my own. I could have afforded like one, but I wanted three. And now I have three. I can go across the entire machine. I could hold a giant chunk of aluminum all the way across my fixture plate. I built a Saunders MachineWorks fixture plate as well as this one. The super glued parts in this metal, I was a little worried they might pull up when I started clamping down, but that's not going anywhere. This is definitely good. This is more than enough force for the cutting forces that my CNC router will produce. Like, I mean, if this was on a mill, maybe the super glue may be an issue, but on my router, absolutely no issue at all. It's gonna be awesome. I'm really stoked to make this. As you can see, I have a piece that I was working on in here, and this piece popped loose when I was trying to hold it in an MDF fixture. It got wet from my super ghetto water bottle. Can you see that? My water bottle fog buster, or whatever you want to call it. Homemade. It actually works pretty well, but especially for the amount of, again, back to the router, the amount of energy I'm putting into this thing is not getting it super hot, so this is more than enough to keep it cold. Also more than enough to warp MDF, and this came loose, and I didn't actually want to build these vices. I wanted to build them further in the future, but I needed them for this project in order to finish this guy right here. So I'm going to salvage this guy later, and I'm going to hold it using these vices, and it's going to be so nice to have these because I've been working completely without vices. I've done some other work holding things. I have some stuff for holding flat stock and some stuff like that, but no vices until just now. And now I have 3 vices that can fit over this entire surface. And one thing that is true about a router as opposed to like a mill is even though I can't cut as heavy and stuff, I can cut on a much larger surface. So I can put these vices and hold a giant chunk of thing. If my machine was that accurate, there's a lack of perpendicularity in this machine, and eventually I'm going to tear down this machine and try to put it back together and see if I can get that out at some point. But and if that's the case, I can definitely reuse the vices. I'll be able to, because they're precise enough that I could reuse those on a once I finish the machine. I may make a new fixture plate if I do that. Anyway, this was a lot of fun. Bit of a detour from what I normally do. I'm building an Iron Man suit, and that's what I'm normally working on. This is a bit of a detour, but this is going to be so nice. This is a great shop upgrade. It's going to be really nice to have these vices. And my hat's off to you, John. I really like your product, and you know, I had to build my own, but don't worry, I'm not going to sell them. They're just for me, because I don't have the ability to sell them. So thanks for watching, everybody. This is probably a very long video. It's going to take me a long time to edit, but I hope you liked it as much as I liked building them. If you're new to the channel, hit subscribe. It would help me out. And come back very soon, because we're going to be building some really awesome Iron Man suit parts very soon. And I'll be walking in the lower body very soon. This is like, these parts right here are the last parts that need to be machined for the lower body. So cool stuff is coming, and I love you guys. Bye.